So, good evening. In the yesterday's session, we started a new batch on data structures and algorithms. Data structures and algorithms with Java. Data structures and algorithms with Java. Coming to this course, the duration of the course is 2 months. The timings of the session is from 6 p.m. to 7 p.m. Okay, so weekdays from Monday to Friday, every day 6 p.m. to 7 p.m. session will be there, where you are going to get running notes along with that images folder. Even we are going to share the videos also. But these videos you are going to have access for 6 months, so the period for this videos is nothing but a 6 months access you will get. And the fees for this batch is 2500, sir, where live classes are very, very important. If you are unable to attend, then it is okay. But maximum try to attend live classes. There are some special topics are there, which I am going to take only on weekends, like arrays, strings, linked list, binary search tree, and AVL tree. These 5 topics. So because it is a lengthy topic, so if you want to avoid confusion, slowly I have to explain these concepts. That's why I'm going to take a separate weekend session on this. Not on every weekend, sir. Not on every weekend, maybe alternatively like that. Yes, course completion certificate we are going to provide. And in the last session itself, I explained what are the topics that we are going to cover as a part of this course, like introduction to up to advanced level concepts. In every data structure, we are going to see the implementation, as well as I'm trying to explain 1 or 2 applications also. Sir, coming to the first chapter that we started already, nothing but recursion, recursive algorithms. How to develop a recursive algorithms we started. As a part of this, what is mean by method? Why we need to go for methods concept? Why we need to go for methods concept? If you have any problem statement, can't we solve that problem statement directly? Why again we are going for the concept of methods? That I explained very clearly, sir, by taking multiple examples. By taking multiple examples, I covered. So whenever these methods are executing, how the control flow will be? Internally, it is going to maintain a stack. Always the latest method execution is going to be invoked. The latest method execution is going to be invoked. So that part also I covered very clearly yesterday, sir. Okay. Sir, next and after that, introduction to the recursion also I covered. What is mean by recursion? A method which is called by, okay, a method which is called by itself is called as a recursive method, and that process is called as what? Recursion. Just I explained one basic scenario which always causes infinite execution, where you are going to get stack overflow error. How to stop that stack overflow error? That part only we are going to discuss in today's session. Even I explained what are the continuation topics for this recursion chapter, like infinite recursion, finite recursion, like one by one we will see. Sir, up to this, do you have any doubt? Please confirm.
No,
Sir,
sir.
up to this, do you have any doubt? Everyone, please try to speak. Then only, so you can able to match with my flow. Okay, please confirm. Everyone, clear?
Yes, sir, it's clear.
Yeah, if you are clear, then I will start. Can I start today's topic?
Sure, sir.
Right. Yeah, good. Sir, coming to the next one. Yeah, no problem. The people who is new to today's class, no problem. At the end, I will share the yesterday's class video. Don't worry at all. Okay. Sir, if you go to YouTube, okay, if you go to YouTube, sir, there you can see yesterday's class video is there, sir. Just refer before coming to this. Why? Because I told already, data structures is not that much easy. Okay. Yeah. Let me talk about where we have that data structures and algorithms. So it is a playlist as of now. Yesterday's video was updated. Just you can go through. Okay. So this is the permanent link. In this, all demo sessions will be there. So demo sessions, all demo sessions will be there in this link. Okay. Especially the person who is new, just I am sharing. Go through that. Now, sir, coming to infinite recursion, can anyone tell me what is mean by infinite recursion as per the name? Yes, what is mean by infinite recursion? A method which is called by itself and never terminates. Sir, in its lifetime, it is never going to terminate. Such a type of recursion is called as what? Infinite recursion. If you want syntactically, sir, I have void m is there, sir. Void m is there. Sir, what I am doing, I will write some instructions and then again I am going to call the same method. How the flow of control is happening? Sir, someone is going to trigger main method, then it is executing these two calls. Again, it is calling the same method. Again, it will execute these two. Again, it will call. Again, it will execute these two. Again, it will call. Again, it will execute these two. Again, it will call. Sir, is it going to end? Never, sir. Such a type of recursion is called as what? Infinite recursion. Okay, if you want, I think yesterday we had one example. What is that example? Sir, if you want, just have a look once. Yesterday, we discussed one example like this. Okay, sir, it is previous batch class is there. I don't want to delete that. Let me take it as a demo. So I'm going to save this file with the file name demo.java, sir. Okay, sir, I'm going to call a method m. What that method is going to do? Public static void m. So it is not going to print anything. It is not going to print anything. Sir, 1 second. Please wait 1 second. Yeah, sorry for the delay. Now I'm calling m method. The control came here. And internally, what is happening? Sir, it is printing some message. Okay. Like, hello group, how are you? Something like this I'm printing. Sir, what will happen? It is executing only one time. Just let me compile java c demo.java. Perfectly compiled, fine. I am running. You can see, hello guru, how are you? That's all. Sir, I'm going to call again the method m. What will happen? Infinite execution is going to be happen. Yesterday only we have seen this. It is a never-ending process, but somewhere it will terminate. Somewhere it will terminate. When it is going to terminate? Whenever you are getting stack overflow. So internally, I told it is going to maintain a stack. Once if that stack is full, sir, sorry, I can't able to accommodate calls like this. I will terminate. Like that, it will switch off. Sir, this type of recursion is called as what? Infinite recursion. Sir, never recommended to go for infinite recursion. But just I want to cover as a theoretical part. That's why I have taken this. Sir, up to this, do you have any doubt? Please confirm.
No, sir. Clear.
Clear, everyone? Please confirm. Right. So what is another one, sir? After infinite recursion, what is the next one? Finite recursion. Some people are not at all responding. So what is mean by finite recursion? Can I say a method which is called by itself, a method which is called by itself, okay, and a method which is called by itself and terminates at a certain point, okay, at a certain point. Sir, you can give some point. So it is going to terminate exactly at that particular point. Sir, example, sir, here, instead of calling like this, I will use some condition, sir. Array boss, first check some condition. If the condition is satisfied, then terminate. Terminate. Otherwise, continue. Then what will happen? It is keep on going to check every time it will check some condition. But to meet this condition, very, very important. To meet this condition, we have to pass some parameters. Sir, majority of the students are having these type of doubts. Sir, I know recursion, but if they are giving any problem, I am unable to solve this. Yes, you can't. Why? Because, sir, the internal structure of recursion you need to understand. You have to check a condition. For this, we need some parameters. Based on these parameters, we have to check the condition. If the condition is not satisfied, you have to send a new parameters to this method call in such a way that it should terminate at finite steps. Slowly, one by one, step by step, I am going to increase the complexity of the problems. There you will get more clarity, sir. Same parameters we have to pass. This type of style is called as what? Finite recursion. So, hello Guru, how are you? I want to print hello boss. Hello boss, how are you? Like this. Sir, how many times I want to print? Sir, I want to print exactly 5 times. Then what will happen? I will pass that value 5 here. So it is a integer value, right? Receive that. And after printing this, first time completed, right? Can I call for n minus 1? Yes. Sir, see the flow of execution. First time I called m of 5. Sir, what is doing? There are two instructions, sir. The first instruction, it is printing. So, hello boss, how are you? Something like that. Then, sir, have you observed m of same method it is calling by passing n minus 1. N minus 1 is nothing but 5 minus 1, 4. Again, it is a method call, which is going to print hello boss, how are you? And it will call for m of 3. So again, it will print hello boss, how are you? And it will be called for m of 2. Again, it has to print hello boss, how are you? It should call for m of 1. Again, it should print hello boss, how are you? It should call for m of 0. Sir, count first time, second time, third time, fourth time, fifth time. Sir, can we stop here? Yes, that is the condition. Whenever the value of n is becoming 0, then please come out. If you take return, what will happen? Immediately, the control is going to come out from this method call. The instructions are never going to be executed. Once if any return statement is found, immediately what will happen? The control is going to coming out. This is nothing but the scenario what is happening. I think diagrammatically, sir, what I have written, it is very clear for you. But let me check, really is it working or not? We have to cross check, right? Sir, I am going to compile the code and I am running. Have you observed here? First time, second time, third time, fourth time, fifth time. Like that, the message got printed. Sir, everyone feeling comfortable up to this, whatever I have given? If you are having any queries, please let me know. I need response from everyone. Please confirm. Clear?
Yes, sir, it's clear.
Clear, friends?
So, sorry, this is because I just cut off in between because my power issue. So just wanted to know, sir, that method m we are using n minus 1. So how it works basically, that I just wanted to.
Sir, here we are giving 5. Okay. So the receiving value is 5. It will check is it equal to 0. No means it will print this message. Again, it will call for the next time. But next time we are changing the parameter in such a way that that parameter should return 0 at some certain point, then I will terminate this process. What is that point? I need to print 5 times. So try to reduce. Then what we have to do? Whenever n value becomes 0, you can terminate. Sir, can I take in this style also? N is equal to 5. Whenever n is equal to 10, then we can return. N plus 1 we can take. In any way you can write. So what is the matter here is how many times you need to print. That is your concept. Understood, sir?
Yeah, got it, sir.
Right. So this type of recursion is called as finite recursion. Sir, I'm giving this diagram along with the code as it is. Okay. So have you observed the same diagram? So same diagram I'm going to share in this format. The total diagrams, whatever I have explained, everything will come for you in this style, sir. Okay. Now, sir, coming to this is the program what we have. Sir, I hope no doubts on finite and infinite recursion. Sir, what is the next one that we have? Very, very important. Sir, observe carefully. What is that one? Base condition. Base condition. Sir, very, very important concept, sir. Majority of the students are going to ignore this. Sir, what is this base condition? Sir, to terminate. Okay, so to terminate or so to stop flow of execution, okay, or to break the loop, okay, to break the function or method call, to break the method call, we have to write some special condition. So which is called as base condition, sir. Base condition is nothing but what? To terminate. So it will become what? Finite recursion. So we need always a finite recursion. And very, very important, sir, once if the base condition, is satisfied, recursion will stop. Automatically the recursion is going to be stopped, sir. And very, very important point, sir, we have to write base condition very clearly by identifying so all possible inputs. By seeing all possible inputs, we have to write a proper base condition. Example number 1. Sir, I can take this program itself is an example because we have written base condition, right? Can you please tell me in this particular program, sir, which line is base condition? Can you please confirm in this program?
N equal
Which
to 0.
line is base condition?
N equal to 0.
N equal to 0. Sir, is the base condition is okay for all possible inputs? Please confirm. Clear? Suppose if I am giving -5, what will happen, sir? Is it a finite recursion or infinite? Are you seeing? Because -5, is it equal to 0? No. Print and -5, -1, -6, -7, -8. It never be 0. That's why immediately we are going to get a problem. Sir, instead of writing n is equal to 0, better to take if n value is less than or equal to 0, then you can stop. Now what will happen? The code is going to compile fine. And even, sir, it never executed. Why? Because you have given a negative number. It never executed because you have given a negative number. Like that, we need to prepare base condition very clearly in such a way that it should stop at a certain point. Sir, everyone, clear?
Yes, sir.
Right. Sir, okay. What is mean by direct recursion? Sir, it's a very simple, sir, theoretical point. Direct recursion means, okay, it is a special case. It is a special case in recursion where a method calls some method. A method calls some method, okay, which which in turn calls same method, which in turn calls same method. Sir, I don't want to take any example program, just syntactically I want to show. I have void m is there. Sir, I am going to write some instructions here. After that, I am going to call the same method. It is called as what? Direct recursion. Sir, there is one more recursion is there called indirect recursion. What is mean by indirect recursion? Sir, it is a special case. It is a special case in recursion where a method calls some method which in turn calls another method. Okay. So that method redirects to previously called method. That's all. This type of scenario. If you want example, sir, I have void m1 method is there. Void m1 method is there, which is having some instructions here, and I am calling m2. Sir, after this, what is happening? M2 method will get a chance. Sir, M2 method is having some instructions to execute. After that, again, I am calling M1. Have you observed? M1 is calling M2. M2 is calling M1. It is a never-ending process. It is also a recursion. This is called as what? Indirect recursion. Direct recursion means a method which is called by itself. Indirect recursion means a method which calls another method that in turns call same method. Sir, clear up to this? Any doubt? Please confirm, guys. Sir, why no response from your side? Please confirm.
It's clear, sir.
Yes, sir.
Right. The next one, need for recursion. Sir, why we need to go for recursion? For every problem, can I go for recursion? Never. Don't go for recursion because recursion is going to take much time complexity, sir. I will explain in further classes what is time complexity. So recursion is going to take more time. That's why maximum try to avoid. But if there is no situation, then compulsory you have to take the recursion. Sir, I can handle 5 students at a time in my class. Sir, if I am taking a small room, if I am taking Java classes, for 10 members, I can manage. For 15, I can manage. Sir, if the crowd is 500 or 1000, I can't able to manage. Sir, even though I'm a trainer, so I can't manage all the 1000 students at a time. But anyway, the delivery person is myself only. So compulsory, we need some kind of assistance. We need to maintain some hierarchy. There should be some manager, so receptionist, fees collector, n number of schedules we have to plan. So like that, for every problem, don't go for recursion. First identify, is it a very small, simple means you can solve by using some math algorithms. If it is not solvable, then we have to go for recursion. First point, sir, we can reduce length of the code. Such type of problems we have to solve by using recursion. Sir, I asked you to calculate or I asked you to generate, sir, combinations. I have given a string like a. I need combinations. Only a, sir. You can write a small program. I have AB is there. Sir, AB, BA. You can write somewhat complex. ABC is there. You can take a loop. Sir, ABC. So ACB. Okay. Then BAC. Okay. BCA. Then CAB. So CBA. Like that we can. Sir, if the input string is ABCDEFGHI, do you remember? Almost 3 plus 3, 6, 9. 9 factorial cases you are going to get. Almost some thousands. Is it possible by using a loop? No, which will become very difficult. But if you write a recursion for that, whether it is a complex problem or simple problem, sir, you are going to get a common scenario. That is the first point. Sir, if we have any common pattern, then only we have to take a recursion. I told already, sir, addition of 2 numbers, no problem. Addition of 10 numbers, sir, recursion we can take, right? Yes, because there is a pattern in every problem. You are going to calculate addition only. So definitely you can solve that. Very simple code we can take. Okay, like we have a common pattern, then only we can. Sir, I have one addition, two subtractions, one multiplication, again one addition. There is no proper format. Sequentially we are doing, not possible by using recursion. Then, sir, there are some best example areas are there where we can take recursion. Can anyone tell me some examples for recursion based problems? Tell me some problems which we can solve only by using recursion. No idea. Okay, fine.
Factorial problem, sir.
Yeah, factorial problem. But my suggestion is factorial, don't go for recursion. You can use loop because it is a simple, right? Understood? Then any other prime number program, you have to take only by using loops. Okay, like that. But we can also solve by using recursion, but never recommended. There are some problems like, sir, Fibonacci sequence. Have you remembered this one? There is
Yes.
a common pattern. What is that common pattern?
There will be some amount or these numbers between the two numbers. It is
Yes,
incrementing or
yes,
decreasing.
yes. That is called as Fibonacci. Sir, even there are some real-time problems. N stairs problem. Okay, even if you remembered towers of Hanai, all these we are going to discuss in our classes. How to calculate towers of Hanai. For first 2 to 3 cases, it will be easy. Okay, then it will become very difficult. Sir, even we have some divide and conquer technique is there. In that also, compulsory you have to take the help of recursion. Sir, even subsets problem. Okay, and even, sir, binary tree traversals. Okay, in all these cases, we are going to use recursion. There is a huge demand is there for recursion in these areas. Sir, are you clear why we need to go for recursion? Remember these 2 points to reduce the length of the code, and if any common pattern is there, immediately we have to go for recursion. Are you clear, friends, up to this?
Yes.
Any doubt? Right. Sir, next, I want to take properties. Properties of recursion. Are sir, can you please write some properties of recursion? Yes. What are the properties? Only 3 properties. First property, sir, performing same operation, multiple times, with different inputs. This is one property. Why? Because if I am calculating addition of 2 numbers or addition of 10 numbers, sir, same operation repeatedly we have to do. Sir, second one, in every step, okay, in every step, what we have to do? Sir, we will divide. In every step, we will divide the problem into simple problems. In every step, we are going to divide the problem into very simple steps. Then third one, sir, you have to tell. Only 3 steps are there. Tell me third one, sir. What is the property of the recursion? Which one we need to remember?
Termination.
Condition to terminate.
Very good. Base condition to stop or to terminate recursion. These are nothing but main 3 properties for any recursion related programs. Are you clear with these properties? Clear, sir? Then coming to the next one, steps to implement recursion. Sir, the first step is nothing but we have to define base case. This is very, very important. At the very beginning only, you have to write the base case. Then we have to define recursion case. Two cases will be there. One is to stop, second one is to continue. When we have to stop, when we have to continue. These two things are mandatory. Third step, sir, we have to write logic. We have to write logic to terminate. That means it is not base case. We have to write a logic to meet that base case condition. And at last, sir, we have to combine the solution. We have to combine the solution, which can be done by stack internal. These are the 4 steps that we have. Sir, if all these theoretical concepts are clear for you, there is one more difference is there, one more main concept is there, like a tail recursion and non-tail recursion. I will explain this and then I will move for the programs one by one. Are you clear with this, friends? Please confirm. Sir, clear everyone? Please confirm.
Yes, sir.
Good. Sir, what is mean by tail recursion and what is mean by non-tail recursion? Both I am going to cover in a single stretch. Listen, sir. Listen carefully. What is the first one here is tail recursion. Sir, what is mean by tail recursion? Inside recursive method, okay, inside recursive method, after recursive call, if we are not taking any statements, so then such type of recursion is called as tail recursion. Are you seeing the difference? Sir, inside recursive method, after recursion call, sir, this is my recursive method. After recursion call, sir, is there any method that we are executing? No, sir. Assume here I want to print the value for n. Just I am printing. Sir, after this recursive call, can I say, is it recursive call or not? Yes. After this recursive call, is there any method? No, sir. Then such type of recursion is called as what? Tail recursion. I want to show you the control for this tail recursion, which is very, very important. Observe, friends, internally what will happen. Sir, I told one separate box, one separate stack will be created internally. One separate stack will be created internally. Sir, first what we are doing, assume I am calling for 5, sir. What will happen? First, the control will go here. It will check is 5 is less than or equal to 0. Condition not satisfied. Then output print the value of n, sir. What is the n value, sir, at current? Please confirm. What is the n value?
5.
5. 5 will be printed. Why? Because at the very beginning we called for m of 5. Then what will happen? Sir, it is printing the value 5. It will print. And is it going to call for m of 5 minus 1, 4? That means this one is going to call another method, which is nothing but m of 4. Now what will happen, sir? Again, it is going to execute. Sir, it will print the value of 4. The output will become 4. Then what will happen? Again, it will call for m of 3. So the control will go here and it is going to call for m of 3. Sir, next m of 3, it will print the value of 3. Again, it will go for what? M of 3 minus 1, which is nothing but 2. So it is internally calling another method called 2. Sir, this one is going to print. It will print the value 2. And internally what will happen? It is calling 2 minus 1, 1. Sir, it is printing and it is internally calling 2 minus 1, 1. Then it will print 1. It will print 1 and internally it will call for 0. Sir, whenever we are getting m of 0, have you observed? Condition satisfied. Then return, come out. At the time of coming out, it will check. Is there any pending instructions are there after recursion? No. Then delete this entry and come. Is there any pending instructions? No. Delete this entry and come. Is there any pending instructions? No. Like that, is there any pending instructions or not? It will check and then it will come. So that this is the output for this program. Sir, if you are feeling any difficulty, please let me know. Sir, clear up to this? Everyone feeling comfortable?
So, sir, just one doubt. So while printing this value, it will be going to like follow that LIFO, right? Last in.
Yes.
Okay.
See, what is happening, where last in first out is happening after execution of M0, already value got printed. The control will come here. So you executed some task. Again, you did some other job. After that, is there any pending job for you? Like that, it will check. Which job method it will execute first? What is the recent call? That job. After that, what is the recent call? That job. Are you getting my point?
Yes, sir.
This is very, very important. This is very, very important terminology, sir. Why? Because the story of complete recursion is depending on that one only.
Yeah, got it, sir.
Yeah, everyone clear?
Got it.
Good. Now, so this is nothing but what is happening internally. This is nothing but what is happening internally. Just I am erasing this and let us execute. Sir, we know the output of this particular program. The output is nothing but what? It is printing 5, 4, 3, 2, 1 like this. Because the first time 5 only, then 4 like that. Sir, next, after this, non-tail recursion. Sir, inside recursive method, after recursive call, if we are not taking, okay, so if we are taking, actually not taking, right? If we are taking, so if we are taking any statements, if you are taking any statements, so then such a type of recursive method, such a type of recursion is called as non-tail recursion, sir, which is internally called as backtracking. Our next chapter is backtracking only, where we are going to solve Sudoku problem, n-queens problem, such a type of things. Sir, what is happening in these? Instead of taking this statement here, so I am taking the statement here. That's all. Only thing is nothing but what? After this recursion, I am taking. Sir, this recursion is called as what? It is a non-tail recursion. Sir, theoretically, if you are clear, then the flow of control I will explain. Clear, friends? Clear up to this? Right. Sir, see the flow of control. Sir, first I called m of 5. So first it is going to maintain a stack. Inside that, someone called m of 5. Okay, this is the output what we have. And sir, first time is 5 is less than or equal to 0, it will check. No, condition not satisfied. Then, sir, see, it is calling m of 5 minus 1, 4. It is not printing anything. So, internally it is calling what? M of 5 minus 1, 4. Then, sir, is 4 is less than or equal to 0? No, sir. Again, it is calling internally m of 4 minus 1, which is nothing but 3. So, it is calling m of 3. Then, so what will happen? Again, it is calling m of 2. So, internally it is calling m of 2. Again, m of 2 is calling m of 1. Internally, it is calling m of 1. Sir, again, it is going to call m of 0. Sir, it is calling m of 0. Whenever m of 0 is coming, control is coming out. Majority of students are going to feel once if return statement encountered, the control will come here. No, sir. There are some statements. There may be a chance having the statements after this one also. Sir, this tail is called as what? Non-tail. But still execution is there. Up to this clear? Please confirm.
Yes, sir.
Now, sir, observe carefully. I am changing the color. Sir, whenever m of 0 is calling, simply it is returning, nothing is doing. It will delete this entry and the control will come back. M of 1. Sir, already the statement got executed. Is there any pending instruction is there or not? Please confirm. Please confirm. Is there any pending instruction to be executed? Yes. SOP of 1. Am I right?
Yes, sir.
So it will print that SOP of 1 so that output will become 1. Then it will delete this entry and it will come. When you called m of 2, directly you controlled. But here there is some pending instruction is there, right? Execute that. Then it will delete and it will go to m of 3. Sir, is there any pending instruction? Yes, print the value 3. Again delete this. Again it will come back. So is there any instruction? Yes. Sir, print. So which is going to print 4. Then it will come. Sir, is there any pending instruction? Maybe the order is not followed by myself. Just you can check it. So like this we are going to get. And it will delete this entry and it will go to the main. That's all. So the output what we are getting is nothing but this one. If you want, let me check really is this output is coming or not. Sir, I am keeping the previous output also. Have a look once. 1, 2, 3, 4, 5, 6. Sir, everyone feeling comfortable up to this? Any doubt?
No, sir.
Clear everyone? Right, that's all. This is nothing but what is mean by tail recursion, what is mean by non-tail recursion. Anyway, the applications I will explain in the next session. But before leaving this, one small important note. Sir, very, very important note. Wherever normal iterations and reverse is required, then better to go for recursion. Sir, they are asking reversing a string. Happily, you can use recursion. They are asking reversing a linked list. Go for recursion. Palindrome or not, go for recursion. Okay, so like that, if anywhere reverse concept is there, blindly you can go for which one? Recursion. Sir, if everything is clear for you, that's all about today's session. Tomorrow, continuation of recursion will be there, where I am going to explain some 4 to 5 examples. Now, if you are having any queries, please let me know. Any doubts up to this?
No, sir.
Right. The people who are interested to continue this batch, you can start making the payments. Okay. Tomorrow also demo link will be there. Maybe from day after tomorrow, we may change the link. Okay.
Yes, sir. What, sir?
Any queries? Is there any brochure of syllabus of this batch? I already told, right? In the beginning, I have given the syllabus, right? You can go through our website. There it is there. If you want, just I will copy paste this in the chat window. You can take for reference. And again, I am repeating the timings of the session is from 6 to 7. Right, guys? Thank you. See you in the tomorrow's class. Bye.
Yes, sir.